Example, we have the sum from n equals 2 to infinity, n+1 over the square root of n to the fourth minus n. This one I'm going to use a limit comparison test because basically if we consider this fraction, this is approximately n at the top, and then the bottom it's the square root of n to the fourth, and the square root of n to the fourth is just n squared, which is 1 over n. So n over n squared is 1 over n. So let's compare our original series to 1 over n, and we're going to take the limit as n approaches infinity. So why don't we just take n+1 over n to the fourth minus n, divide by 1 over n, which whenever you divide by 1 over n, that's the same thing as multiplying by n. So this n is going to multiply the n+1 to get n squared plus n over n to the fourth minus n. The next step, I'm going to multiply, or if you want to think of it, divide everything by n squared. So multiply by 1 over n squared or divide by n squared. So then n squared times 1 over n squared is 1. N over n squared is 1 over n. And now inside the square root, 1 over n squared is going to go in as 1 over n to the fourth. And so we simplify this further. Okay, 1 plus 1 over n, and then 1 over n to the fourth times n to the fourth is just 1, and then n over n to the fourth is just 1 over n cubed. And here notice that 1 over n goes to 0, 1 over n cubed goes to 0. We have 1 over 1, so the limit is 1. And the way limit comparison test says, well, sum from 1 over n diverges, we know, because it's a harmonic series. And because the limit is positive and finite, that means our original sum will also diverge. And that's by the limit comparison test.